a particular lecture looks at probability, but in probability, we are starting from our module of biostatistics. And in biostatistics, I'm very sure in your previous interactions, you have been able to discuss what biostatistics is. Therefore, we want to just look at a certain part of biostatistics, which mainly looks at probability in this particular lecture. However, we are having particular objectives for this particular lecture here. And I was saying that after this particular lecture, we expect that as a student, you should be able to define probability, but also you should be able to understand some of the basic properties of probability. You should be able to understand some of the different measures or methods of probability. You should be able to calculate the probability of simple and compound events using the different formulas and rules. But you should be able to apply, most importantly, the concepts of probability to the real world situation. So if you're a demographer, you should be able to apply probability in your real aspect of demography. If you're a public health expert or scientist, or you're a nutritional dietist, or you are an environmental scientist, and so forth, in your own particular field of study, you should be able to understand this particular probability, but also how you should be able to implement it in those particular aspects of, in the various aspects in which all of you might attest to. So we want to understand the introductory part of probability by trying to figure out what we understand by probability. And in this case, we're saying that probability is about figuring out the chances of something happening, ranging from what we call impossible, which is a zero, to a certain what we call one. And we're saying that probability helps us make sense of these uncertain situations and make better decisions. So just imagine you have a group of about 10,000 people and you want to select 10% of them randomly. So the question would be that what is the probability that any of the 10,000 individuals can be selected? So in other words, you're making inferences, or you're making you're trying to understand, or you're trying to figure out what the chance might be for an individual to be selected among the 10% from the 10,000 people that you have. So probability, the probability of zero, like we said, a zero would imply that the event will never happen, and the probability of one would imply that the event is certain to happen. So in other words, for any event that has probability zero, it would mean that uh, that event will not happen. For example, having the sun at the night hour, that is a probability that will never happen. Meaning, there is no way we can have the sun during the night, and during the day we have a different thing. So whereas one implies that the event is certain to happen, meaning that it is going to happen. You're very sure that the event will certainly happen. But again, we're saying that usually these events that have probability zero or one are not very interesting to discuss. So you cannot discuss the outcome of something that you are sure about. You cannot discuss the fact that something will not happen. The discussion will become a little monotonous, and at the end, it is a very boring discussion. But also similarly, you cannot actually have a discussion on an issue where you know the result is going to be 1. So, for example, if you do not do a paper, you know that you're not going to have results. So that end is already determined. So you cannot discuss modalities of how you may not be able to do a paper, but at the same time that you might have opportunity to have marks. So that discussion may not be able to yield in that aspect. So the notion P, where we are referring to as currentness, the notation that we're saying here as P with something in parenthesis after, such as we're saying the probability of A. So P is used to represent the probability of A happening. So in any regard, you can be able to write probability of A, where P is our parenthesis. And in that parenthesis, like we said earlier in our definition of probability, we are trying to figure out the chances or the so that something will happen. But so that is why we're saying that in that reference, we're saying the parenthesis A would mean to represent the probability of A occurring. So there are different descriptive notations that we can actually use. For example, we can say the probability of people having diabetes. So in your own field of discussion, when you want to understand the population structure, or you want to understand some of the issues affecting your society in terms of probability. And so we were saying that when you're starting to use these descriptive notations, you may choose to use a descriptive notation based on your event of interest. For example, if you wanted to understand the probability of under 5 deaths, in other words, you want to understand the mortality rate in the society. So you would be having data for all mortality in the society, but for you, your interest, your event of interest is mortality under 5. So your notation for the parenthesis here would be the probability of under 5 death. So that is just an explanation of P in brackets, the event of interest in there. So if we wish, or we can use letters to represent you can use this discrete of female, probability of under 5s, probability of individuals who have diabetes, but also you can say probability of individuals who live in urban setting, depending on your event of interest. So there are mainly two ways to determine probabilities. And one is by considering the situation theoretically, such as games of chance. And then what is the chance? Well, we just theoretical consideration. This is useful if it can be done, but we cannot possibly do this when we want to do something like estimate the prevalence of diabetes among the US population. In that case, we must use data to establish the desired probability empirically based upon our observational data. So in your first way or method of using theoretical, for example, in a football game, there will be a win, there will be a loss, there will be a draw. So theoretically, you can. This is a game of chance. So in a game of chance, you can just use a theoretical decision and say this is going to be a win. What many people call as gambling is also a probability. It's an application of probability. But again, the second way of the application of probability, or how we can determine probability, is by using estimate or by using data that is already available. For example, if you wanted to estimate the prevalence of diabetes in the UK, then you should be able to use the population that is at risk. the population that is at risk vis-a-vis the cases of diabetes. So it means that you already have an observational data, that you already have data that you're basing on. For example, if you had let me use the case of malaria. If if your population that is susceptible to malaria, or that the population that in other words, if you wanted to estimate the prevalence of malaria in South Sudan, then you should be able to have, this is the second way you're not using a theoretical method in trying to determine probability. Here you're actually using you're using observational data. So to determine this prevalence on malaria, you should be having observational data on malaria. So if malaria cases in this month, in the month of October, were 4,050 positive cases, you should be able to subject this particular figure of 400 malaria cases to the population that is vulnerable, possibly meaning in malaria, uh, almost all the entire population is susceptible, or can actually get malaria. So you could subject it to 10,000, or I mean to 10,000 of the population. So let's say you have 4,000 50 cases in the month of October, and then here you are with your population of 10,000. So you should be able to calculate this 4,050 and divide it by 10,000, and it should be able to give you the figure that can give you the probability. So you can be able to see what would be the probability that out of 10,000 people, uh, uh, the number of people who can get malaria. So that is the probability that we are explaining in this statement, that is up here.